Welcome to the final college algebra video. Now, I know that many of you are already in my physics class and you've already seen the video in physics about this. I had this huge spiel of things I wanted to talk about. So if you haven't seen the thank yous and all the things that I've wanted to say about how much I really appreciate you, I'm putting the link to that video down in the description below. But otherwise, I don't want to waste your time. I know you want to get through this lesson so that you can be done with math, and that's no problem. So we're going to go through this lesson as hopefully as painlessly as possible. I tried to make the last lesson relatively straightforward and, hopefully as much review as possible and nothing too extraordinarily out there so that because I know you have a lot of probably a whole ton of things to do this week, and I don't want this to be overbearing on you or on top of everything else. So I tried to make this as light of a week as possible. But we'll we'll see what happens. But just to get into it, so I don't waste your time, let's just talk about what we're gonna do today. I've got 5 problems I want to look at, and each one is a lot of the same thing, just nuanced in different ways. The first 3 are are just solving for a particular variable, something you've probably heard of before and you might be pretty familiar with now, solving for a variable. And the last 2 are, or excuse me, I suppose the last 3, the first 2 are solving for a variable. The last 3 are solving for a compound inequality. Something we've talked a bit about before, but we haven't really just dug our heels in and and really just mastered to the nth degree. And so we're just going to try to make sure we are familiar with both of these to a good enough point so that if we saw it on the entrance exam, we'd be all right. We'd be good to go. So let's, without further ado, here's solving for a particular variable, especially when there's a lot of variables involved. There's a whole set of steps I'm giving you right here. Now be aware that I am over explaining this. I'm giving you more information than you need. And you can figure this out in probably fewer terms and fewer steps than what I've put in here. But I'm putting down all these steps so that if there is anything that's catching you or anything that's not quite making sense, I'm trying to be as exhaustive as possible. So don't be overwhelmed by the fact that there's so many steps involved. There's so many things here. I'm just trying to really, really explain it thoroughly, so you probably can skip through a lot in your head. Anyway, so if I want to solve 2a plus 1 equals 6vw for a, the first step that we do in these kinds of problems is to try to get the variable we're looking for, and the examples and steps I put here, it's x. You want to try to get the variable we're looking for out of the denominator. Now, fortunately, there's no fractions here. If there was a denominator, like an a or an a, we'd want to get that out of the denominator, but we don't have that here, so we can just skip the first step. If it were here, I'd want to get a out of the denominator. Let's say it was like a times n, for example. If I wanted to get that out of the denominator, I'd multiply both sides of the equation by an. And now get rid of a on the left side and leave me with 6vw an on the right side. Fortunately, we don't have any of that. All we have is this right here. So we can skip step 1. Step 2 is get all the variable, or in our case, all of the a's to one side of the equation. Okay, fortunately again, we only have one variable. We just have a. So it's already on one side of the equation. So if there's only one variable, we can skip step 2. Again, if there was something like a 6vw plus a, we'd want to make sure we get there's an a on the left side and an a on the right side. We want to get them both to the same side of the equation. So I would subtract a from both sides. Just to get you familiar with this, just in case this kind of comes up in the homework assignment, and we'd subtract a on both sides. So there's no a on both sides, so we'll just skip that step as well. The third one is combine like terms. There's only one x, or in this case, only one a. We only have one a. This is going to get a little more complex in the next problem, but I'm just trying to make this as simple as possible at first. Because again, you can skip a lot of these steps. I'm just trying to be as exhaustive as possible so we can cover all our bases. There's only one a. So we can just skip everything else. We can skip step 3, so you don't have to combine like terms. Step 4 is get the variable, in our case a, by itself. Get rid of the numbers around it by doing the opposite of what they're doing. The first thing we start with is the numbers that are, or the terms, the numbers, or anything that's furthest away from our variable, furthest away from a. And in our case, the things furthest away from a, that's on this side of the equation, I probably should specify, furthest away from a, on on its side of the equation. The things that on its side of the equation is this one here. Now, when you do this, you're taking the entire term. So if it was like 1c or something like that, you would take the whole 1c and try to move it over. Fortunately, it's just a 1. So we're going to take this entire term, this entire set of group numbers and letters, which just happens to be just a 1 right now, and we're going to move the whole thing over. And when we do things like this, we take the entire term and move it over, an entire group of numbers or letters, again, just 1 in this case, we will use addition and subtraction. So we'll subtract this from both sides. So subtract. So a big windup, so we can just do one thing. We're going to subtract 1. So it gives us 2a equals, not AA, that'd be something else. 2a equals 6vw minus 1. Great. All right. And we'll finish. That was the first step in number 4. The second step in number 4 is to finish with the numbers that are touching our variable, that are touching x, such as 2x or x divided by 2. In this case, we've got 2a. And we've got 2a, so that's actually a 2 times a. These numbers that are touching are being multiplied or divided. So we have to do the opposite of what they're doing. So this is 2 times a, but it's touching, so it would be 2 times a. An example of it being division would be a divided by 2. That'd be a time when it's dividing. But if they're just touching, like 2 and a together, that's 2 times a. So we'll do the opposite by dividing. If it's 2 times a, whatever it is, whether it's multiplication, division that's happening there, you want to do the opposite of it to get rid of the variable. So it's multiplying, so we want to divide by 2. Divide by 2. These 2's cancel out, which leaves us with just a. That's how we get rid of a variable. We just do the opposite of what it's, or not get rid of a variable, that's how we get rid of a number. We do the opposite of what it's doing. On the right side, we're left with 6vw minus 1 all over 2. And that's it. That's really an answer. Sometimes we'll need to simplify it or change it a little bit so it looks like more like one of the answers that are in the answer boxes. If we need to simplify it a bit, so here's some things we can do. An example of something we can do is we can say that this is all over 1 fraction, so we can split it up into multiple fractions. We could say a equals 6vw over 2 minus 1/2, but that's a little less simple. It looks like more now instead of less. This looks the simplest, and this is simplest. And because it's simplest, we'll go with that one. And that's actually, when you look at CUDA, if you're given this problem, that's actually the one you'd prefer. But again, the idea is that you can move things around so that it would be a different answer. Another thing that it could be switched around with to get a different answer, you might get something like, you could switch that -1 with a 6vw and get a equals -1 plus 6vw over, let's change that fraction, that's a bit too big, over 2. And that would be also a valid answer. We could switch that -1 and 6vw. So we can use these properties. If things don't look exactly like the answer you're looking for, try to make sure you manipulate it to get the answer you're looking for. Don't just say, oh, it looks close enough and I'll go with that one, because sometimes it may be kind of, it's looking to see if you've done the thing right. If you've done it wrong, if you've done the computations wrong, then you may end up with a wrong answer. You may think, oh, that one's close, but close is not the same thing as right. And in math, close is never enough. It's always got to be the same. Anyway. Okay, second problem. This one's a little bit more complex. We'll go through the same steps, perhaps a little bit more rapidly, now that we've kind of walked through the steps once. The first step is get the variable out of the denominator. Get x out of the denominator. And this time we're solving for x, but x is not in the denominator since it's no fraction, so we'll skip step 1. Step 2 is add or get all the x's to one side of the equation. Okay, all the x's, there's 2 x's in this time, but they are both of them are on one side of the equation. So we can skip step 2. they are both on the same side of the equation. So we'll go to step 3. So if they were not on the same side of the equation, it would look like x plus g equals all of that stuff. Then in that case, well, we'd say, yes, that'd be something we need to work with because there's an x on the left side and on the right side, but that's not our case. They're all both on the right side of the equation. So we'll go to step 3. Step 3 says, combine the like terms, so there's only one x, and this might require factoring. So we need to combine these like terms. There's 2 ways of thinking about this. I'll just quickly go through both. And whichever one works for you, just go with that one, because you can do it both ways in the 99% of the cases. So we could say minus 4cx plus 2yx. You can think of it kind of like if you had 2a plus 3a, that equals 5a. So you can kind of think of it that way, and you could say this is minus 4cx plus 2yx. You could say this is minus 4c plus 2y times x, if that makes sense to you. Maybe if I was to put it in a more full way, it's 2a plus 3a equals 2 plus 3a, which equals 5a. That's kind of what you're doing in your head when you kind of put these two things together. Your head is just quickly, and it says, and its mind is saying, okay, it's 2 plus 3 times a. That's what it's doing. And once you understand that, you can say, okay, I can take that same principle and apply it here. For minus 4cx plus 2yx is minus 4c plus 2y, all that times x. Now, if that doesn't make sense to you, no problem. Here's another way of thinking about it. If you could say in the same way that we have, that if we had let's say 7 and plus 14, 7x plus 14x, and we wanted to, let's say 17x squared and 14x, and we wanted to factor out as much as we can. We're going to pull out from both of those as much as we can the like terms, or the like terms that are common among both of them. We could say, well, among the numbers, the 7 and the 14, there's a 7 that's common, so we can pull out a 7. So 7 times x squared plus 2x. This is one way of thinking about it. And so you could say we've got that, and then after that we can pull out, what else can we pull out? We can pull out an x. So we can pull out an x, we can say 7x. And so if you pull out an x, let's see, x squared, if you divide that by an x, you get x. And then 2x, if you divide that by an x, that just gives you 2. So it gives you 7x, x minus 2. Same thing with this. We can pull out numbers. We can do what's called factoring, pulling out numbers. And we can pull out, let's see, on both sides of the equation, we can factor out, we can pull out, not pull out both sides of the equation, on minus 4cx plus 2yx, we can factor out, we can pull out an x from both of those. So because there's a common x. So we can say this is x times minus 4cx divided by x is minus 4c. And plus 2yx divided by x, that's just plus 2y. And that's another way of doing the exact same thing. You see that in the top version, this top method, we get one option, minus 4c plus 2yx. In the bottom version, we get x times minus 4c plus 2y. We get the same thing, so both ways are valid. The point is, though, we end up with one or the other. Let's say, for example, let's just go with the second one. G equals x times minus 4c plus 2y. Okay. So we've done that. We've combined the like terms. We've combined them. We've factored out the x. Whichever one we kind of want to think about, combining like terms or factoring out x. Now we need to go on to the next step because we have just one x. So now that there's only one x, we found one x. We can go on and get x by itself. We need to get rid of the numbers around it first. The furthest away from it on that side of the equal sign, and then the numbers that are closest to it on that side of the equal sign. Okay, the numbers that are close to it, the numbers that are touching it, well, the numbers that are furthest away, there's nothing that's furthest away. It's nothing being separated by a plus or minus. It's away from it. We can kind of say the only thing that's close to it, the only thing that's there is something that's touching it. This giant parentheses of a thing. This giant parentheses of a thing is what we're talking about. this parentheses is touching it. And so we got to deal with this touching. And we say, okay, it's x times minus 4c plus 2y. Since they're touching, if there's a line underneath them, we'd say it's dividing, but they're touching, so we'll say it's times. And we'll do the opposite of that. Well, because it's times, because it's multiplying, we'll do the opposite. That's what this side says. Now that we find that they're multiplying, they're touching, we're going to do the opposite. We're going to do division. I hope that's not too overwhelming. So we'll divide by minus 4c plus 2y, divided by minus 4c plus 2y. Okay. I feel like I'm repeating myself a whole lot, and I'm sorry if you're like, oh, this is so basic, and he just keeps rambling on about the same thing. But I feel like some of you might really find it helpful by the fact that I'm trying to re-explain it in different ways a bunch of different times. These are the same things. It's x times negative 4c plus 2y. It's the only thing that's touching it, so we have to, because we find it's multiplying, we have to do the opposite to get rid of it. We have to divide. Okay, so that gives us g over minus 4c plus 2y equals x. And that is literally our answer. There's nothing we can do about that. We could, if we were to write it a different way, we could see that minus 4c and plus 2y, we could switch those if we wanted to, and we could say g over 2y minus 4c. Now that's not a simpler way of writing it. That's not simplifying per se, but it is just another way of writing it if you need to find another answer. The things that are plus or minus, they can swap around like that just a bit. Okay, but for our intents and purposes, that's our answer, and that's probably what the answer box is going to look for. It's probably not going to ask us for the second one, just for the first one. But just so you can know, you can make that kind of operation. Okay, great. So that's the first type of problems that we're dealing with. The second type of problems we're dealing with are compound inequalities. Here's how we do those. Okay, it depends on what it's saying, whether it's saying or and, or something that's just kind of strange, doesn't look like or and. We're going to talk about each, we're going to give an example of each of those and how to solve them. And I'm going to start with or, because I think or is the most straightforward. Or if you can understand or, you can understand all of them. Yeah, so let's look at it this way. If we have a compound inequality and it says 6p is greater than 24, or p plus 10 is less than 8, we want to find a way to simplify this and a way to understand what this is saying. Well, it's in essence trying to solve it, which is also another way of saying simplifying, but that's something we don't need to get into too much right now. For our sake, we're trying to solve this inequality. Let's go with those words. The first thing we want to do every single time is we want to solve the inequalities as themselves. We want to solve each inequality. So let's say we'll take 6p is greater than 24 and p plus 10 is less than 8. We need to solve for p in both cases. So let's start with the first one. I guess I'll start with different colors just to make it distinct and clear. The left one, let's do blue. Not blue, purple, let's do purple. 6p is greater than 24, and then for the right one we'll do blue. P plus 10 is less than 8. Okay, so for the purple one, to solve that, we'll just divide both sides by 6. And we'll get p is greater than 24 divided by 6, it's just 4. So p is greater than 4. And remember, when we're doing inequalities, we solve inequalities the exact same way, precisely the same way as we solve equations, as even the equations we've been solving up here. We could use the same steps too. But we're trying to solve it in the exact same way as equations, but with one important rule. There's only one important rule you gotta know. If you ever divide or multiply by a negative number, you switch the signs. You turn it from greater than to less than, or greater than or equal to, or to less than or equal to. You make that switch. Okay, and you can think of it this way. If you say like negative 3 is less than 7, the way to think about it is if I multiply both sides by negative 10, negative 10, multiply that by that, and this times negative 10, we get 30 is less than negative 70. Now we know that 30 is not less than negative 70, so we need to switch the sign to make sure it makes more sense. We'd say 30 is greater than negative 70, because negative 70 is a really big debt. We owe $70. I'd rather have $30 than to owe $70. Anyway, I hope I'm not getting too far off track. I hope it's helpful more than just boring. Okay, so we solved the first equation. It's the first inequality. Let's solve the second inequality. P plus 10 is less than 8. To solve it, we'll subtract 10 from both sides. Minus 10, and we'll get P. Remember, we're subtracting 10 now. We're not dividing by 10, so we don't switch the signs. We're just subtracting. So we're left with P is less than 8 minus 10 is negative 2. Okay, so we'd only change it if it's multiplying or dividing. All right, now that we've done that, that was step 1. Step 2. Actually, let's use green to make it clear that we're doing distinct steps. Let's not make it purple because that might be confusing. Then we're going to graph both inequalities. We're going to graph both of them so we can kind of see what's going on here. Let's go ahead and make a graph. Let's make a graph just like this. And let's say we've got, this is 0, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. Okay, so this one, the purple one, says P is greater than negative 4. So that means you start with 4. So it's greater than 4. So we start with 4. That's the fourth one. And then we do all the numbers greater than it. I use an open circle, just in case you're curious. I use an open circle because it's greater than, not greater than and equal to. If it's greater than and equal to, we fill it in, but it's not, so we don't. So it's greater than 4, so P is all the numbers larger than 4, so we'll draw an arrow to the right. Okay, and then P is less than negative 2. So we'll start with an open circle at negative 2. And we'll say P is all the numbers that are smaller than, that are less than negative 2. So if I want to find numbers that are smaller than a negative 2, I'll go to the left. So left this way, just like that. Great. All right, so here's what I've got. And in order to understand this, in order to digest what's going on here, we need to see it in light of this little idea on the left. Well, let me explain what's going on here on this third step before we try to analyze what we just did in step 2. For step 3, we're kind of understanding that everywhere the arrows go, that is part of the solution. So we're really asking a question. We're asking a question that says, where can you find a point that is on line 1 or line 2? So the purple line or the blue line. If it's on either of those lines, if it's on one or the other, then we can say it's part of the solution. So we can say, so for example, if they were diverging on the left and right, in this first graph here, if they're diverging, they go left and they go right, we will just take both graphs just as they are, and we'll say that's our answer. We'll just rewrite the equations, and that's your answer. If they overlap, like in the second one, then we'll say, well, hey, anywhere I can find a point on line. Let's say this blue one here. This blue one is x is greater than or equal to 3, and the green line is x is greater than or equal to 5. You can notice that, hey, anywhere I find a point on the green line, I also find a point on the blue line. Anywhere that's on green is also on blue. And so because of that, no matter if I just say all the points on the blue line, I will find all the points on the green line. I don't need to say both. I don't need to mention the green line because it's kind of like inside the blue. If I just find all the points that are on line 1, I will find all the points that are on line 1 and line 2. There's for line 1 or line 2. If I want to find any point in line 1 or line 2, it's going to be on the blue line. Any point in line 1 or line 2 will be on the blue line. Maybe that's the more helpful way to phrase it. Any point in line 1 or line 2 is on blue line. So we can just write the blue line. The blue line is our answer. X is greater than or equal to 3. The last one, you'll notice, they kind of overlap in the center, and then they go out to both directions. So if you're asking the question, where can a point lie on line 1 or line 2? Where can I find a point on line 1 or line 2? Well, pick any point you want. It's no matter which point I pick, I will find a point on line 1 or line 2. There's nowhere on this graph I can go that I won't find a point on line 1 or line 2. So I would say the answer is just all the numbers, all the real numbers. Or you can use that fancy R for the answer as well. Okay, so we want to see our graph in terms of what we were talking about right here. So let's look at here. We've got two lines that are diverging. They kind of go in opposite directions. And so we can we'll basically just write it the exact same way as before, because it looks, I'll find a point on line 1 on the purple line. If p is greater than 4, I'll find it on that right purple line. And then, or if I find a point anywhere where p is less than -2, I'd find a point on the blue line. So both of these are possible answers. And so we would just write p is greater than 4 or p is less than -2. You could switch it up if you want to. You could say, I don't know, you could say p is less than -2 or p is greater than 4. You could move things. If you really wanted to get fancy, you could go back and forth and say -2 is greater than p. I can switch the whole thing. I just kind of mirrored the whole I guess statement there. P is less than 2 also means that -2, or p is less than -2 also means that -2 is greater than p. They were both kind of going that same way, because in both instances, if you were brought up in a class like mine in elementary, you got alligator teeth. The alligator teeth want to eat the -2 in both cases. So it's still saying the same thing. The alligator wants to eat -2 because it's a bigger number. Okay, let's see. And then I could write, if I really wanted to, I could write that, or 4 is less than p. So I could write it that way. But for our sakes, most of the time, we're going to find something that's pretty similar to what you've written. P is greater than 4, p is less than -2. Great. So that's ORs. That's how we accomplished ORs. For ANDs, we just think a little bit different. We start off doing the exact same thing. The first two steps are the exact same. You solve each inequality, and you graph both inequalities. The way we analyze them will be a little bit different. So we'll first solve these and then graph them and see where we can go from here. So we have -2 plus v is less than 6, and v over 5 is greater than 2. So if I want to solve for the left inequality, I want to get v all by itself, so I'll add 2 to both sides to get rid of that -2. So that gives us v is less than, let's see, -6 plus 2 is -4. -4. And then we'll go on, and that's just solved. That's v is less than -4. Let's solve the second one. V divided by 5 is greater than 2. To solve this, I will need to multiply by 5. So 5 times 5, because I'm doing the opposite of division. This is one of those cases where it's touching, but it's touching with a fraction sign. So we'll do multiplication. We'll do the opposite of division. We'll do multiplication. Okay, these cancel out, and we get, and remember, we are multiplying by a positive number. We're not multiplying by a negative number, so we don't need to switch the sign or anything. We're multiplying, or dividing in this case. We're multiplying or dividing. In this case, we're multiplying, but we're multiplying, but we're not multiplying by a negative, so we don't have to switch any signs or anything. So v is greater than, let's see, -2 times 5 is -10. So that's that. The second step, that's step 1. Step 2 is to graph it. So we'll just make a graph here. Okay. And we'll start with -4. So let's see, 1, 2, 3, 4. So v is less than -4, so we'll start with -4. An open circle, because it's not less than or equal to. And then let's actually make this color a little bit different. Let's say this is v is less than -4, and let's make it orange, just because that way you can distinguish it from the line. Okay, so it's less than -4, so that means it's all the numbers to the left of -4. So we'll go to the left like this. Okay, and then we'll go to v is greater than 10. So we'll go v is greater than -10. Oh, I should have drawn this a little bit better then. 5, 6, 7, 8, 9, 10. Let's say that that's what that is. I'll extend this orange one just a little bit further so you can kind of, so it's not too crowded. There we go. Okay, now let's make this one, let's make it green. V is greater than -10. So let's say this is -10. We use an open circle for that one. And let's see, we have to go all the way to, we have to find all the numbers bigger than -10. So that means we're going to go to the right. We're going to go to the right like this. Okay. So now we've graphed it. You can kind of see it does one of those overlapping things. And on one side we go to, and then after that it splits off into both directions. Instead of there being a gap in the middle, it's filled in. It's overlaps in the middle. Okay, so when we get to step 3, then we ask just about the same question, but we modify it just a tad, and it gives us very different answers. So the question is a little bit different now. The question is now, because it's an and, we're trying to find a point that's on line 1. We need to find all the places where we can find a point that's on line 1 and line 2. Where are all the points that are on the orange line and the green line? Where's that range where they cover each other, where they overlap? And that's what we're trying to look for here. So in this case, if we were to go back to the same exact equation from the same exact graph from before, we would say, well, there's no place here where I can stick a point down and say I found a point where that's on in this first one, where there's both a blue point and a green point. There's no blue and green point on this first line, so there's no solution because it's not combined. There's no blue and green at the same time. The second one, it's asking, well, it looks like, well, there is some blue and green at the same time. There's a lot of points that I can point to that have both blue in them and green in them. So that's all the values where x is greater than or equal to 5. Because again, the 5, the green line is inside the blue line. Anywhere that I have a green line, I will also have the blue line. So they always overlap wherever the green line is. So our equation is just x is greater than or equal to 5. That's where the point where they both mix and they overlap. The third one looks at this and it looks like, well, okay, there's a really small gap where they overlap. You can see they overlap right in the middle here, between between 2 and 4, they overlap. And because there's a filled in circle on 2 and a filled in circle on 4, they also include points 2 and 4. Those points are also included. Okay. So we'd say it's just the places where x is greater than 2 and x is less than 4. This is literally what the equations, these are the actual equations that are given. X is greater than 2 and x is less than 4. There's a couple ways to write this though, and then if you get to an entrance exam, they might format it a couple of different ways. So I just want you to be aware of the couple of different ways you could see it pop up. They could also write it as x is greater than or equal to 2, comma, x is less than or equal to 4. Or you could write, or they can combine them into one, and they can just stick the x's together. Remember how I said we could flip an equation? They took the first one. They took the x is greater than or equal to 2, and they turned it into 2 is less than or equal to x. So they took x is greater than or equal to 2, and they flipped it. The 2 is less than or equal to x. That's a valid move you can do, as long as you swap the direction of inequality as well. So they did that swap, and then they combine that with x is less than or equal to 4. So 2 is less than or equal to x, and x is less than or equal to 4, and then just squash those x's together. So you got 2 is less than or equal to x, which is less than or equal to 4. So they kind of squash them together just like that. And that's how they get this third one. So it could come in all these 3 different ways. This last one is usually the most official way. This is the most preferred way. So if you see something that looks like this, you'll just, if you want to separate it in your mind, just kind of separate those into 2 equations. Just separate it back into 2 is less than or equal to x, and x is less than or equal to 4. And then kind of work from there. That kind of helps me understand it a little bit better. when I see something like that. Okay, when I see that, instead of just this 2 is less than or equal to x is less than or equal to 4. We could also think of it, if you don't like that, you want to think of it in a different way, totally, you can think of it in a different way. If this helps more, you can think of it as 2 less than or equal to x less than or equal to 4. In that range, you got 2 and 4 as the bookmarks, you got x in the middle, and you just put less than or equal signs everywhere. It'll always be less than or equal to. Every single time, it'll always be less than or equal to. I'd welcome you to figure it out on your own, figure it out as to why that is, and to kind of understand the intuition behind it. But I'm going to move on because I respect your time. So we got a situation like this over here. We've got a negative 10 on the left. Let's say that's a negative 10 on the left, and we've got a negative 4 on the right. And we've got x in the middle. And they overlap, which means we've got one of those funky, we've got one of those they overlap a little bit, which means we have this last third condition. So we've got to figure out how to manage this well. In this third condition, we can write it in a couple different ways. I can just say, well, it's negative 10. And now because it's an open circle, we still follow the open circle, closed circle rules. If it's an open circle, we're still going to keep that less than sign. We're not going to put in the equal sign as well, because we want to make sure we know if I plugged in a point at precisely at negative 10, well, it wouldn't be on the green line, because the green line doesn't include negative 10. There's a circle, there's a hole there. So we would say it does not equal, it does not work at that point, because I could get the orange line but not the green line as well. So we'd say negative 10 is less than x. And we'd also say, or I guess in this case is v that we're dealing with. Negative 10 is less than v. And we'd also say that v is less than negative 4. Again, for the same reason. There's a circle at negative 4. There's not a filled in circle. It's a circle, not a dot. Okay. And we can bring those. You notice that these are the exact same things as in one. As in one, we got v is less than or equal to 4. V is less than 4. V is less than 4. On the other one, we have v is greater than negative 10. You flipped it, you mirrored it to get negative 10 is less than v. Okay. Now, finally, can I not erase those? Oh, bummer. Well, at least I can't undo those, but I can erase them. So that's good. So finally, we just smash them together to make one giant inequality, and we'll say negative 10 is less than v, which is less than negative 4. Okay, very verbose, but I hope that was clear as to what we're doing here. The last situation is conveniently simpler. Well, there's not much else to know for the last situation. It's kind of just the other situations, just slightly different. Here's what I mean. If you start with one of these messy equations, it's like negative 100 minus negative 10n minus negative 100 is less than negative 10n, which is less than or equal to 50. You can figure, well, this is not or and. What do we do? This one's actually really simple. You can just split this up in the same way that we can combine things together. You can make this like this and this. We had this and this. We can split these up, back up into two and equations, and then work it like a normal and equation. So this becomes negative 100 is less than negative 10n, and negative 10n is less than or equal to 50. And we'll just go from there. That's all you have to do. And then after that, it's exactly like one of these problems. And I'll quickly solve this last one just so you can kind of get the feel of what we're doing. But it's going to be exactly like the last one. So that's step one. No, step one is to solve for n. So we're just going to go ahead and solve for n. We're going to divide both sides by negative 10. Now be careful. I'm dividing by negative 10. You know what that means? That means we flip the sign. So if we divide by negative, we're gonna flip this sign first of all, and these cancel out. This is n. Negative 100 divided by negative 10. That is a negative divided by a negative, which is a positive. 100 divided by 10 is 10. And on the right side, we have negative 10n is less than or equal to 50, we'll divide both sides by -10. And again, we're going to flip that sign. Flip that sign. It sounds like a game show or something. And we'll get n is greater than or equal to 50 divided by -10, and positive divided by a negative. A positive and a negative come together to make a negative. So negative 50 divided by 10 is 5. Okay, so our equations are 10 is greater than n, and n is greater than or equal to -5. We're going to find the places where they overlap. So we will go ahead and just go ahead and make our graph here. And I'll make 0 over here so it's kind of clear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then n is greater than 10, so we'll start at 10, make an open circle because it's a greater than, and then let's see, 10 is greater than n. 10 is a larger number than n, which means that n is smaller than, or n is less than 10. So we'll choose all the numbers that are less than 10. We do all of this over here. Great. Okay, and then we have n is greater than or equal to -5. Oh my, I messed it up. I thought I was going to make this work. I just wasn't. I still didn't. 2, 3, 4, 5. Let's extend this green line so we're kind of clear. And I will, let's see, this is a red line, so we'll start at -5. But it's greater than or equal to, so I'll fill in this circle. Now it looks like Christmas. We're going to say n is greater than or equal to -5. So that means n is larger or equal to than 5. So it's all the numbers bigger than, which means you go to the right. Go to the right. Okay. And we'll go ahead and draw our arrows just like that. And let's see, so we got to find, because it's an and equation, we got to find the places where it overlaps. And we say, okay, it overlaps. The places where I can find 2 points is from this -5 all the way up to the 10. Okay, so what we can say is it's from -5. Let's see, the way I phrase it up here, I just want to make sure that I'm not just doing something very different from you. Yeah, so we can say it's -5 is, since they overlap, we'll just write both of them down. So -5 is greater than or equal to n. And we'll say, let's see, and that's just the reverse of what we just wrote up here, if you're curious. -5 is greater than or equal to, -5, excuse me, I'm writing this wrong. Good thing I tried to clarify, otherwise I wouldn't have catched it, and I would have made you all really confused. This is -5 is less than or equal to n. -5 is the smallest number. We always use less than or equal to. We never use greater than. What was I thinking? So -5 is less than or equal to n. And then we'd say, so -5, same thing as saying -5 is greater than or equal to n. Okay? Those are saying the same things, I just flipped it around. No. There we go. Now I'm actually thinking like a mathematician. There we go. -5 is less than or equal to n is just this one flipped around. You flip the 5 and n, and you flip the sign. So you can do that. That's what we did here. And then we'll say 10 is, we go all the way up to 10. So we'll say the second equation is the green one, and we say n is less than, n is all the numbers that are less than 10. And so we can say it's and n is less than 10. Okay, so then now we can just smash these together, and we will get -5 is less than or equal to n, which is less than 10. Simple as that. And that's our answer. So, hope that's helpful. Again, thank you all so much for being in this class. I had a lot of fun with you all, and I really enjoyed being with you and learning so much about mathematics. And I really loved it. I'm really thankful that you all let me to go off in these wild tangents about how math is somewhat elegant and beautiful, even if it's hard, and even if the mathematicians made the language a lot more cumbersome and mean and evil than it needed to be, and even if we're in a fallen world where it's not really designed our brains aren't really designed to understand it as intuitively as possible. Like things just this even if it's just a struggle because this is work and all work is toil and hard, and this is a really great example of it. I really hope I got to show you just a little bit about how beautiful math can be, um, and I hope you're able to at least see a little bit about how it can be something that can be appreciated and can be enjoyed. Um, it's math is not just a it's just a thing. It's also an experience, and although I'm finishing this up without being able to see any of your faces, I have been really glad to experience math with you, especially because when I was doing it, I got to see God in many, many new, beautiful ways. Um, anyway, I'm getting off sidetracked. To see again, see the video in the description if you want to see everything else. But thank you all so much for this class. Thank you for being here and being part of it and really actively engaging. I've really enjoyed it, and I really enjoyed being with you. And I really hope you all get to do really great and amazing things. Um, because you all are really cool people, and I think you all can do really, really amazing. I know you all will do really, really amazing and cool things. So, anyway, I'm rambling now. I'm just, I just feel really bad that we're leaving, and this might be the last time I ever get to speak to you. And oh well. Um, maybe I'll see you at graduation. I will see you at graduation, and I'm really looking forward to it. Well done, you all. Well done. Making it through the rigors and the mess that Christ Chapel can be sometimes. Um, I know what it's like, and you all have run the race and you've made it through, and so I congratulate you. Well done.